I think most people never actually think about what happens when they power on their computer. It just turns on. But if you actually try to describe that process, it gets weird really fast. Let me show you something. So, according to the system, startup takes about 5 seconds, split into kernel time and user space time, which already feels more complicated than the word booting suggests. But the part that bothers me is that we treat this like one simple process, like you press a button and Linux just appears, while clearly that's not what's happening. So, what is actually happening before this line exists? Let's actually rewind all the way back. Before Linux, before grub, before anything is loaded from the disk, this is where everything begins. When the computer gets power, the processor doesn't know what Linux is. It doesn't know what Windows is. As a matter of fact, it doesn't even know that there is a hard drive. That's easy to forget, because we are starting at the end of story. Right now, Linux is already running, but a few seconds earlier, none of this existed. So if the processor doesn't know about operating systems, how does it know what to execute first? Something has to give the processor its very first instructions. That something isn't Linux, it's firmware. So if the processor starts by executing firmware, what exactly is firmware and what is it doing? Is it part of Linux or is it something completely separate? So there isn't even an EFI folder, which tells me that this machine wasn't booted using UEFI. But that doesn't mean that there isn't firmware. It just means that this system started in legacy BIOS mode instead. Whether it's using BIOS or UEFI, the important idea is the same. Before Linux can do anything, the firmware has to get the boot process started. This is the first software that processor executes. Its job isn't to run Linux. Its job is to figure out what should be run next. Okay, but what exactly is next? What is the firmware actually looking for? As we know, it's not exactly looking for Linux. So this is where things start to make more sense. Linux isn't something the firmware understands. It's just a collection of files, and one of those files exists for a very specific reason. And that reason is to bridge the gap between firmware and Linux kernel. So let's take a closer look at the bootloader grub. So we've found the bootloader, but what does it actually do? Let's take a look. At first glance, this mostly looks like configuration. So we have menus, we have options, we have paths, like those. But buried in here is important part. The bootloader is told where the Linux kernel is and where the initial RAM disk is. So when you choose an operating system, the bootloader loads the kernel into memory. it also loads the initial RAM disk, and then it hands control over. After that, the bootloader is finished and the Linux is in control. Think of the bootloader as a relay runner. Its job isn't to keep running, its job is to actually hand control to the kernel. So now Linux is finally running. But there is still a problem. The kernel isn't ready to use the whole system yet. It still has one more obstacle to solve. So at this point, Linux is finally running. But as I mentioned, we are not done yet. And that is because starting the kernel isn't the same thing as starting the operating system. Let me show you something. This confirms that we are running the Linux kernel and that the handoff from the bootloader has already happened. So the grub is out of the picture now. But the kernel still has one very important job. It needs to mount the real root file system. And that is where the rest of the operating system actually lives. The kernel is alive, but it cannot start systemd until it has access to the real root file system. So something still has to happen here. So then how does the kernel reach the real file system? That's where things get a little strange, because to finish starting Linux, it first starts a tiny temporary Linux. Okay, I said that Linux first starts a tiny temporary Linux, and that's actually a useful way to think about it. But let's be more precise. It's a temporary user space called the initramfs. So by this point, the Linux kernel is already running, but it may not yet have everything that it needs to mount the real root file system. And that's exactly what the initramfs is there to solve. So let's take a look inside the initramfs. What we are seeing here is the content of the initramfs image. Notice that this isn't just one file, it's an entire file system. It has programs, configuration files, and directories. And on top of that, there is this initial program that coordinates the rest of the startup. This environment exists for one purpose, and that is to prepare the system so the real root file system can be mounted. And once that job is finished, the boot process moves on. Okay, so to recap, the bootloader has already handed control to the kernel, but before the real operating system can start, the kernel enters this temporary environment. And its only job is to prepare the system for the next handoff. Once that is complete and the root file system is available, then this temporary environment is no longer needed. And the boot process continues with the real user space. So at this point, the system is finally ready to leave this temporary environment behind, and the real root file system is mounted. Now, the operating system can begin starting its normal user space. And that starts with a single process, process 1. So let's actually see what that looks like. This is the real root file system. Everything from this point on is running from here. The temporary environment has done its job, and now the normal operating system can take over. Every process running on Linux has a process ID. This one is special because this process one is the first user space process started after the switch to the real root file system. On this system, that is system D, and from here everything else begins. Okay, so as we established, the initramfs has finished its job and the root file system is mounted. Now the real user space begins. And it begins with a single process, which is process 1, which is system D. From system D, it starts networking, it starts logging manager, it starts audio, and many other services running in the background. By the time you reach desktop, all of those services are already running. The desktop isn't another step in the boot process, it is just the result of everything that came before it. Alright, let's look at the entire journey one last time. So it all starts with the power button. Then the CPU begins executing the firmware. The firmware decides what should be run next. And the bootloader loads the Linux kernel. Linux kernel starts executing, and a temporary environment prepares the real system. Once its job is finished, it disappears. System D becomes the first user space process, and it starts networking, a logging manager, audio, and many other services. And eventually, this is what you see, a Linux desktop. At the beginning of this video, we had one question. How does Linux go from a file on disk to a running operating system? The answer isn't one program as we saw. It is a sequence of handoffs, and each stage does one job and then passes the control to the next one. By the time you reach desktop, the journey is already over. Of course, here we have only scratched the surface. We still haven't looked at secure boot, for example, or what the Linux kernel actually does after it starts. Those are the topics for another time.